In this lesson, we shall focus on mathematics, paper 2, May, June 2024. We start off with the first question. Right now, it is very, very important for us to take note of a couple of things here and make sure that we actually can do very, very well. Something very important is our ability to analyze statistical data. And we have the following question, obviously, that needs to be done. And it is the following. Yeah. Question 1. The number of pages in 10 A4 books and their corresponding weights, right, in grams are given in the table below. The data is also represented in the scatter plot. You also have the scatter plot. You also have the scatter plot. You also have the scatter plot. Okay. Determine the equation of the least squares regression line. 3 marks. Determine the equation of the least squares regression line. 3 marks. Right, let me give you 1 minute to try this one, and then when you're done, let me know, then we shall do the corrections. I want to see if you can remember something, or if you know something about this. You have just 2 minutes, I'm sure, are enough. Right, 2 minutes are enough. I'm giving you like 2 minutes, and when you're done, please let us know. When you're done, please let us know. Okay, yeah, but some of you, of course, forgot this. Yeah, okay, yeah, let me give you a chance. You have 2 minutes. You have 2 minutes. Right, you simply have 2 minutes. You have 2 minutes. Who is done? Who is done? Least squares the regression line. Determine the equation. Least squares the regression line for 3 marks. For 3 marks. For 3 marks. Right. How far, Tondo? Lisedi. How far, Lisedi? How far, Neo? Yeah, if your network fails. Okay, yeah, I've received a message that Lisedi is saying it's done, and then let me check Neo. Okay, yeah. Obviously, I'm teasing you with this, so yeah, let's just practice a little bit. Let's just practice. Here's my calculator. Right, with this calculator, then we start and say mode. Like, yeah, most of you guys have the Casio. So you start with mode, then you do 3 stats. Then you need linear equation, which is least squares regression line. It's a line, so it's a plus bx, so you do 2. And then now you're going to do the x. The x is what? It's 85. And then 150 equals 100. equals 120. We're picking from here, 120, 90, 140, 135, 105, 115, 160. Okay. We have 11 of those. Back to number 1. We do y, which is 85 goes with 165. 325. 200. 250. 180. 285. 250. 170. 230. And then 340. Right. So we have exactly this here. Now with this, then, you actually obviously can press the on button and then you go and now be in a position to look at the stat again. Right, so obviously you need 5 regression. 5 regression. And then now, obviously, you look at the variables you want. For instance, let's see, we need A first. Right, we need A first, call it 1. Minus 43.72. A is minus 43.72. B. Let's do B. Let's do B. Shift 1 for stat. There's stat on top there. Okay, so obviously we're dealing with regression analysis. 5 is the regression. We're looking for B, number 2. 2.36. 2.36. 2.36. Just clean up a little bit. As we do 2.36. Right. Yeah, let's do 2.36. That's fine. So we're going to clear this up. Gonna clear this up. Right, so we are doing 2.36. Which means, therefore, the least squares regression line for the 3 marks is actually always written as A plus BX minus 43.72. Okay, yeah. Minus 43.72. 2.36x. 2.36x. So this is the answer. Where's the question here? Where's the question? Who does not understand what to do? and how to determine the least squares regression line. Who does not understand how to actually determine the least squares regression line? In 1.2, draw the least squares regression line on the scatter plot in the answer book. On the scatter plot in the answer book. Right. So to be in a position to draw the least squares regression line on the scatter plot in the answer book, it is obviously understood that, for example, you have a point here between 80 and what? Between 80 and 100. Now we have 20 here. 1, 2, 3, 4. So it's like steps of 5. So this is like, there's like 85. 85 goes with 165. Right, which is exactly that. So obviously at this point there, you have that point there. And so in the end, what then you do is you need to connect the points. You need to connect the points. So you're obviously no ruler, but this is what you're going to have. Note that this drawing here is such that it cuts through pretty much the center of the data points. It cuts through the center of the data points. It cuts through the center of the data points. Right. That's a good question. How to draw these? Obviously, the way to draw it is to make sure that it cuts through the center of the data points. In which case, there is no hard and fast rule. There's no hard and fast rule when it comes to drawing this, except that you can really see that it cuts through the center. In this case, we realize that if you could put a ruler here, you could realize there's a point there. And then you realize also there's a point at about 85. Trying to connect these 2 points, the first and the last. In this case, we did not quite have a very visible outlier in a way. And therefore, connecting the first and the last and placing your ruler, it was actually able to sort of allow us to draw a line that passes through the center of the data points. Through the center. There's no hard and fast rule here, but obviously on average, then it is to be in the center of the points. On average, it is to be in the center of the point. So you need to. It is an approximate drawing. It becomes obviously an approximate drawing. Right. Well, I mean, the first dot sometimes can be here. And the last one can be there when the others are here. Or the first one can be here when the others are there, or it can be there. In which case, therefore, you'll be like, okay, most of the points are here. If most of the points are here, then it must be through these points that are many. This one, for instance, if that is far, will be an outlier. So in outlier, we just disregard it. So we don't draw anything as such there. We don't draw anything as such there. So we don't try to connect it. We don't try to connect it. But obviously in this case, yeah, yes, you draw through the middle. That is the rule. Just draw through the middle. That's all. But it can't be, for instance, you see, through the middle can't be this, because this is way too out. But now this is fair. This is fair, so it's acceptable. But there's no hard and fast rule, I must tell you the truth. Because the points, we know why is it that there's no hard and fast rule? these points cannot be on one line, all of them, because it could form a zigzag. Because you see, the thing is, if ever there was a perfect line, then the points could be joined by one line, but it's not possible, because then you could do zigzag like this. So it must be just through the middle of the line, of the points. Any question? Let's continue. Right, let's continue. I know it's a bit tricky, but yeah, just take it easy. Next. Next, we look at 1.3. Predict the weight of an A4 book that has 110 pages. Predict the weight of an A4 book that is 110 pages. So you already know that the y is minus 43.72 plus 2.36x. But if this book has 110 pages, x, the number of pages is x, weight is y. So you want to determine the weight is y. The number of the pages x, and therefore you have minus 43.72 plus 2.36. The number of the pages is what? Is 110. 110 pages, and then we can be able to give the approximate weight. And therefore, if we do this, use our calculator. So we're going to have like minus 43.72 plus 2.36 times 110. Yeah, then you get 215.88. 215.88. 215.88. So this is the approximate weight, because now x is the number of the pages. We've already got the regression line. Where's a question on this one? Calculate the percentage increase. Right, we're going to do that one next. But we've found the weight of an A4 book because the pages are 110, which means x is 110 because number of pages is x. You plug in the 110 and then you're able to get the y. And the y is the answer. The y is the answer. The y is the answer. Where's the question? Who doesn't understand how we got the weight of an A4 book that is 110 pages? Calculate the percentage weight increase. Now, something called the percentage weight increase, or what we call the percentage increase. So to find what we call the percentage increase, we do like this. Between a book with 110 pages and a book with 130 pages. So which means, therefore, that y is minus 43.72 2.36x, which is minus 43.72 plus 2.36. X is 130. So let's use the calculator, because now there's a book that is 130 pages. So let's just find the weight. If the book has 130 pages, so it's minus 43.72 plus 2.36 times 130. This is 263.08. 263.08. 263.08. At x equal to 110, we got that y was 215.88. But what we're able to see is that there's an increase here. There's an increase because at 130 pages, then the weight is more. It is 263.08. At x equal to 110 pages, it is 215.88. So we can really see that there is what? There is actually, if the there's obviously an increase in the weight because when the pages are 130, the weight is 263.08. When the pages are fewer, like 110, smaller than 130, you have 200 and what? And 15. So there is a percentage increase there. This is what we do to calculate the percentage increase. So we then say the formula for the percentage increase, which is we're going to make tomorrow, is to say percentage increase. Is to say percentage increase in weight. Then you take the 263.08 minus 215.88. You divide by the network. Okay, I'm so sorry with the network. I'm going to send the recording, of course. Right. Okay. Right. We continue. Right. Okay, yeah, you forgive me the Neville, if you lose, if your network fails. If your network fails, then the recording is gonna be there. I'm gonna try to send it today. So now the percentage increase, it's the biggest one minus the smallest one divided by the smallest one. That is the formula for the percentage increase. The biggest one minus the smallest one divided by the smallest one, you multiply by 100. Okay, so now we're going to use a calculator. So we're going to have, for example, 263.08, 88, and then you can multiply it by 100. 21.86. 21.86%. 21.86%. 21.86%. 21.86%. Who doesn't understand anything? Once again, we are having the recording. So yeah, just in case your network fails. Just in case your network fails, we're gonna the recording is there. The recording is there. So now we found the percentage increase in 1.4. The percentage increase, it's the biggest one, which is 263.08 minus the smallest one, 215.88, divided by the smallest one, which is 215.88 times 100%. And you get the answer. Then you get the answer. Then you get the answer. To continue. Yeah, if your network fails, please, we're recording this discussion. So I'm going to send it after our discussion. Then you can fast forward, you can play around with it. Okay, y'all. Can always make it premiere. Okay, question 2. 50 athletes need to access suitable training facilities. There are 50 athletes that need to access suitable training facilities. The table below shows the distances in kilometers. So you have the distance x in kilometers between 0 and 5 kilometers, 5 kilometers to 10 kilometers, and so on, that they need to travel to obtain access to suitable what? Training facilities. Okay, so you have the distance in the kilometers, but also the number of the athletes, like 3, 7, 20, 12, 5, 3. Cumulative frequency. Complete the cumulative frequency column provided in the table in the answer book. Okay, this one came from the answer book, this table. Okay, this one was in the question paper, but this one I took it from the answer book and I put it here. So we need to actually just complete this one. So to complete this one is very easy, because the top one is 3 and then you put 3. And then the next one is 7. 7 plus 3, you put 10. Right, 10 plus 20, you get 30. You add 12, you get 42. Right? Okay, my apologies now. I can see your network is... Right, I can see your network is failing. You add 5. 42 plus 5, you get 47. You get 47. And then you add 3, you get 3 plus 47, you get 50. So which means that the cumulative frequency is going to be 50. But as indicated, that if your network fails, now we are recording this discussion and our network does not fail. At the point of recording, you're going to have the recording in order. You're going to have the recording in order. So do not worry about the recording. But yeah, I understand that your network might always fail you there. But if it fails you, please take it easy. So now complete the cumulative frequency column in the table. So for the 2 marks, right? For 2 marks, we've completed the cumulative frequency table. You start with the top one, 3, and then 7 plus 3, it's 10. Plus 20 is 30. Plus 12 is 42. Plus 5 is 47. Plus 3 is 50. And so on. Okay, so obviously now we're dealing with 50 athletes. So the athletes are 50. But now let's just look at 2.2. On the grid provided in the answer book, draw a cumulative frequency graph or OGIF to represent the above data. So on the grid provided in the answer book, draw a cumulative frequency OGIF, all right, what you call ogive, right, to represent the data, the above data. Okay, let us draw what you call an ogive. Right, to draw an ogive, we proceed as follows. You'd remember that this one is 3, 10, the cumulative frequency, 30, 42, 47, 50. So we continue. Right. Right. We continue. Okay, y'all. Okay, yeah, so that's what we have. So let us looking at the OGIF now, we're gonna mark it. Like the distance. The distance starts from 0 to between 0 and 5, right? Starts from 0. 0 is included, so it can potentially be 0. Between 0 and 5, then you can see the number of the athletes is what? It's exactly 3. Right, so when the distance is between 0 and 5, then you have what? You have a total of up to 3 athletes, right? Between 0 and 5, then you have exactly 3. You have exactly 3. Yeah, this is the 3 there. So you're gonna have exactly 3. So it is 1, 2, 3. Right. And then obviously a time comes when we are looking at obviously what happens then. Obviously we include the origin. We include the origin. But now we can see that at 10, we have 10 as well. At 10, we have 10. So we continue. Right. We continue. Right. We continue. Okay, y'all. So at 10, you have 10. So you have this one. And then there's 30. Right. All right. We continue. Right. We continue. Okay. We continue. We continue. Right. We continue. Right. So, y'all, we're good. Okay. Next. Okay. Dealing with the cumulative. There's a point where we have like 15. 15 goes with 30. Okay, good. Yeah, we're continuing. Thank you so much. 15 goes with 30. So 15 goes with 30. Right. 15 goes with 30. 20 goes with 42. 20, 41, 42. 25 goes with 47. 30 goes with 50. Right, so this is what we have, and this is our ogive or our ogive. Ogive or ogive. Okay, because it's French. It's French. So the French call it ogive. The French call it ogive, but yeah, in English, normally you can just call it ogive. So this would be the cumulative frequency curve, okay? So spend some time to make sure you're able to understand it, but you're able to see that it stopped at exactly 30, because at the time that we have 30, that it is exactly at what? At 50. It is exactly at 50. It is exactly at 50. Right. It is exactly at 50. It is exactly at 50. So we continue. We continue. You see, the fact that it is 3, this 3 is when we have x is smaller than 5, and when x can be 0, meaning we can go as low as 0. We can go as low as 0 there. Let's move on to the next question. Calculate the interquartile range, IQR, of the given data. So to calculate the interquartile range, you must be able to get like Q3. Right, you must be able to get like what? Q3. And you must be able to get also Q1. And then we're going to get the difference between the two. So let us look at Q3. Q3. So Q3 becomes 3/4. So Q3 is position. His position is 3/4, which is 0.75 of what? Of the total. So at this point, it's going to be 0.75 of the 50, which is this one of 50. And now let us use a calculator for this. Which is 37.2. And then you have 1/4. Zero 0.25 times 50. 12.5. 12.5. Okay, so now, okay, good. Okay, right. What we are trying to do now, right now, we want to just determine the positions. Want to determine the positions. So to determine the positions of on the cumulative frequency curve, like for Q3, it's this one. And then this one is Q1 position. This is the Q3 position. So the Q2 position is what? Is 2/4, or you can say it is 1/2. Okay, so yeah, but that's not what we want now. So we are here. Okay, let us check this out. So now if this becomes like 12.5, exactly 12.5. So you're gonna look at this and be like, okay, 12.5. Then you actually obviously look at the fact that 12.5 of water we are actually in a position to achieve here. Of water we are able to achieve. Okay, yeah, good. So if you then say 12.5, which is like 1/4 of 50, and then now you measure the 12.5, so you're gonna have 10, 15. Then how many steps? Like 1, 2, 3, 4, 5. Yeah. So now this is 10, 11, 12.5, which is 10, 11, 12.5. It's just in the middle there. Okay. Okay, yeah. So you can get about, just say 11. Yes. You can actually obviously approximate your, yeah, but it's more than that. Okay, yeah, you see, yeah, let's say it's estimating it about, but it's 12.5, so it's like 11, 12.5. So 12.5 is like in the middle. So you do this. And then at this point, then you're going to drop it. You're going to drop it down. Yes. Oh, thank you so much. Yes, yes, thank you so much. Thank you so much. You said you're right, you're right. So obviously then the distance is going to actually be exactly what? 11. So this one is going to give us Q1. So Q1 is going to be 11. Well done there, Lisedi. Well done, Lisedi. You're right. Okay, Lisedi is so right. You said it's all right. So Q1. So now there's Q3, which is 37.5. Okay, 37.5 of the 50. So you come here. Right. So now you're gonna actually say 35, 36, 37.5. 35, 36, 37.5. So you're in the middle. You're in the middle. You drop it down when you reach the graph. So let's say has already got this one. So which means that we have Q3, and Q3 is exactly what? Okay, because you can see this is 15. So this is 1, 2, 3, 4, 5. So this is 11. And then this one is 15, 16, 17, 18. So which means Q3 is exactly what? It's exactly yeah, but you see the thing is it's not very much exact. It's not very much exact. All right, I like to. It's close to 18, but it's not. Using your ruler. Because it's just here. Okay, I'm gonna check the charts, Lissetti. So it's not very accurate. Okay. Okay, yeah, I'll have to, yeah, okay, thanks, Noah, for sharing that. So, okay, I want us to try and be very accurate here, because obviously there are discrepancies, but this one is going to actually be 17.8. There is 17.8. It's going to be 17.8. But in the exam, they're going to accept 17 to 19. If a student is going to say 18, they're going to mark them right because it's an estimate, you know. Or if a student is going to say 17, they're going to mark them right. Okay, so, okay. Yes, so that is the thing. All right. So now, yeah. Yeah, so what do you then do? Well, because this one is grouped data, this one is grouped data, you just look at the 3 over 4. 3 over 4 for Q3. Or you can just say 75%. 75% of the total, yeah, for the cumulative frequency. So if you say 3 over 4 over 50, then you get 37.5. And then now we have Q1. Right, so we continue. Okay, any question? My point is you just say, because this is grouped data. Yeah, you divide by 4. Yes, you can always obviously do it that way. But as said already, the most accurate is to do what? The most accurate for grouped data, because this data is grouped, you would see that we got a 12.5 here altogether. So for the 12.5, how did you get 12.5? You said 1/4 of the total. But for ungrouped data, obviously it's different. Then you need to obviously do the additions. But this one is grouped. Obviously, you actually are getting an estimate because it's grouped data. So you can always obviously get an estimator that way, and you can always add, imagine the addition of a 1. Okay, let me see. Yeah, for group data is different because obviously for the ungrouped data, normally we do those particular additions. But here you can just say 75%. And then you get the accurate, because now then we get 12.5 here. You then say 1/4 for Q1 is 1/4. For Q3 is 3/4 of 50. 50 is the total. Right. Obviously now the n+1 rule works very well for ungrouped data for sure. Right. And then now, and once you get this, but obviously even here you actually would can use a similar rule as well. Can use a similar rule as well. Any question? Okay, yeah, but this is we're playing here. So the Q3 we've got, what is the Q3? The Q3 is 17.8 approximately. But yeah, I'll take a wide range of answers. The Q1 is 11. The study got that. The interquartile range would therefore be Q3 minus Q1. Minus 11. Which is 6.8. The interquartile range, the IQR. Who doesn't understand IQR? Who doesn't understand how to find the IQR, the interquartile range? Who does not understand how to calculate the interquartile range is the IQR. What is the semi-interquartile range? Semi-interquartile range. Semi-IQR. If they can ask for the semi tomorrow, they can just change this one to semi. What they're going to say the answer is, what is semi? Semi-interquartile range. What is it? It's half. It's half. Half of this. Half of this. Divide by 2. Okay. Now, if you're dealing with 2.4, the families of 4 of the athletes. The families of 4 of the athletes above who stay between 15 and 20 kilometers from a suitable training facility decide to move 10 kilometers closer to the facility. In which interval will the number of the athletes increase? Okay. This is the thing. The families of 4 of the athletes above who stay between 15 and 20. They stay between what? 15 and 20 kilometers from a suitable training facility. Decide to move 10 kilometers closer. They stay between 15 and 20 kilometers. Decide to move 10 kilometers closer to the facility. In which interval will the number of the athletes increase? Right. Because they actually decide to move 10 kilometers closer, it means you take the 15 and the 20, and then 10 kilometers closer, you subtract 10. Which means that then you're going to have what exactly? 5x10. So in which interval will the number of the athletes increase? They will increase in the 5 to 10 interval. They will increase in the 5 to 10 interval. Why? Why? Because of the fact that they were staying between 15 and 20. But now you minus 10 because they moved closer. So it's 10 minus 5 and then 20. Yeah, it's 15 minus 10 because it's 10 kilometers closer. 20 minus 10 and then you are between 5 and what? And 10. And so between 5 and 10, so that is where it's going to increase, because they're saying in which interval will the number of the athletes increase. So it will actually increase in the interval there. If you expect that to increase from 7 athletes, then there are going to be more athletes who are staying in that distance of 5 to 10 there. If most of the athletes, like 4 of the families of 4 of the athletes. Now they decide we are staying far, we want to move closer. So those who are closer now, 5 to 10 will therefore increase above 7. Above 7. So think about it and make sure you understand this question. Okay, let us look at the next thing. Right, if you look at the 2.5, question 2.5. Calculate the estimated mean distance that the 50 athletes need to travel after the 4 families have moved 10 kilometers closer to the facilities. Right, so now here you're going to do the cumulative. Right, so you're going to do the cumulative frequency. So when you do the cumulative, then it's going to be 3. You add 7, you get 10. You add this one, you get 30. You add, you have 42. You add, you have 47. You add, you have 50. So the estimated mean. The estimated mean. So now we're going to do the middle here. So if you say 0 plus 5, you divide by 2, you have 2.5, yeah, the middle. And here you divide 5 plus 10. Yes, you must use the new number of the athletes. Thank you so much. You must use the new number of the athletes. So this one is going to change. Yeah, this one is going to change because of the new athletes. Okay, I'm gonna adjust that one. But now what you're gonna have, you have 5 plus this one, which is 15 divided by 2, 7.5. Yeah, definitely. Yeah, so this ones will be 11 here. That is the change. This ones will be 11. Right. These ones would be 11. But they're going to change from this because they're between. So now they moved from here. This one is going to be 8 now. Because they were here. They were between 15 and 20. Yes. So now here it's going to be from the 12, we subtract 4. So they're going to be 8 because they moved from here, those families of the 4 athletes. Now they're here. So we added 4. So it became actually 7 plus what? 7 plus 4, which is 11. Then now we have 10 plus 25 plus 15, divide by 2, which is 25, divide by 2, 12.5. 35, you divide by 2. What is 35 divided by 2? 17.5. And then this one is exactly 45 divided by 2 is 22.5. Right, so this one is going to be exactly 22.5. Yes, because now some of the families moved. Families of the 4 athletes moved from 15 to 20. They moved to 5 to 10. 4 of the athletes. So 4 of the athletes now will be added to this group. But they moved from 15 to 20. Those 4 athletes. Okay, they moved from what? They moved from 50, the interval 15 to 20. So now here, 20 plus 25 divided by 2, 22.5. Okay, you add this one divided by 2. Yes. Okay, good. Good. Right. So in the previous question, remember this paper is the June 2024 paper we're doing. I'm going to send you a copy, guys, of the paper. So now the estimated mean, therefore, you're going to take the half. You add this, you divide by 2. You add the extremes, you divide by 2. And then now here we're going to take 2.5. 2.5 we multiply by what? By 3. And then we have 7.5. You multiply by 11. So they can trick you with this tomorrow. If some of the athletes move from one group to another, there are some movements now. They change the numbers. So which means that here you'd have 12.5. 12.5 you multiply by what? 20. 17.5. 8. 22.5. 5. 27.5. 3. Okay, so you add all of them and then divide by what? You divide by the total. Even if the athletes move around, but we know very well that they still remain what? They still remain 50 of those athletes. Now use the calculator, adding the top things here, we get 675. We divide by what? By 50. Use the calculator, we get 13.5 kilometers. And that is the answer. We get exactly 13.5 what? Kilometers there. We get 13.5 kilometers there. What is this? That is the estimated mean distance. The estimated mean distance that the 50 athletes need to travel after the 4 families have moved 10 kilometers closer to the facility. Clearly show all your working. We've shown all the working there. Okay, you got 82.5. All right. Of course, we need to check that one. Let's just check it quickly. Let us check it quickly. Yeah, I know very well there can always be a chance of human error. So what is then gonna do? We're gonna have like 2.5. 2.5 times 3. 7.5 times 11. 12.5 times 20. Okay, I'm checking the messages again. Yeah. Let me see. Okay, I'm trying to check your feedback there. Yeah, because the 50 is the total number of the items, right? Okay, yeah, 12.5 by 20. I'm just doing this. 17.5 by 8 plus 22.5 by 5. 27.5 by 3. Okay, we got 67.5. How many athletes are there? There are 50. So you divide this 675, you divide it by what? You divide it by the total number of the total frequency. And then it becomes 13.5 kilometers. So that the distance becomes exactly what? 13.5 kilometers there. So this is the estimated mean distance. Estimated mean distance. Estimated mean distance. Estimated mean distance. Where's the question about it? Where's the question about it? Right. Okay, let me check. Oh, okay. I understand that, yeah, you did not add everything. So obviously here we're just supposed to say, yeah, let me see. Let me see. Yeah, that's a good question. Don't you just add all the values and divide by 1, 2, 3, 4, 5, 6? Okay, what did you get when you do that, Lisedi? What did you get when you add all the values and divide by 6? Right. What did you get? You got 8.33. Right, yeah, because you see the total for the mean. Okay, I'm trying to check. You see, the formula for the mean is this one. The mean at the back of the metric paper, it is the summation of xi divided by the summation of, yeah, the xi, and then here you multiply by, okay, yeah, how do we, yeah, how we add the total of the mean? Okay, so obviously to get the total, the 50 is the total. How do you get this total? The total is the total frequency. The total here becomes the total frequency. How many athletes are there? That is the total. And then now, if you then actually take the x's, you take the xi's in the middle, then you multiply by the what? You multiply by the individual frequencies. And then you divide by this. So this is the formula for the estimated mean what they're talking about. So you must take the midpoints multiplied by the individual frequencies. So in this case, obviously this is not cumulative frequency. So you take 2.5 times 3, 7.5 times 11, 12.5 times this. Then where do you get the total? The total is 3 plus 11 plus 20 plus 8 plus 5 plus 3. If you add all of them, you get 50. You add all these, you get 50. That is how you get the estimated mean. Where's the question? So this is what we do. So we took the midpoints here. 0 plus 5. So what did we do? We said here, 0 plus 5 we divide by 2. You understand? And then it became what? 2.5. And then we have 5 plus 10. You divide by 2, which is 15.5. Yeah, it's 15 divided by 2, which is 7.5. Yeah? So this is what you get the midpoints, the class midpoints. When you have got the class midpoints, you take the frequencies, yeah? 3, 11, 2.5 times 3, 7.5 times 11, 12.5 times 3, 17.5 times 8, 22.5 times 3. You do that, and then you divide. Where is the total coming from? Okay, you see, we don't divide by 6. We divide by the total frequency. What is the total frequency? It is 50. So we divide by 50. We don't divide by 6. So that the answer is 13.5. In the marking center, this is the answer that we're going to expect from you. This one. In the marking center, that is the answer I want. And this is how it must be done. Where's the question? Who is confused? Who is confused? Because this one is already there tomorrow. This one. Exactly this one is already there tomorrow. I'm telling you the truth. All right, together. So you need to make sure you understand it. Right, so okay, what is confusing? You must get the class midpoints. To get the estimated mean, you must, because this one is grouped data. But how do you divide by 30 if there are 50 athletes? If there are 50 athletes. But you see, we don't divide by this 30. Okay, so you divide it by 50. But you see, I'm concerned about the numerator. Maybe you did not add everything. Because you see, like Neo saying she got 630, but I got 675. Neo is saying she got 630, but I got 675. And this is the correct answer that we expected in the marking center when we're marking the exam. When we're marking the exam, we actually expected the students to get 600 and what? 675. So any answer that is different from that is not acceptable. We don't accept anything. For the estimated mean, we must get this one. You just need to do it manually. You don't use a calculator for this one. You don't use a calculator for this one. You don't use a calculator for this one. You must get the class midpoints. 0 plus 5, you divide by 2, you get 2.5. Okay, good. What do we want in 2.5? We want the estimated mean. How do we get this? The estimated mean, guys, is for what? Is for grouped data. Is for what? Is for grouped data. So if you're dealing with grouped data, you already have classes, right? From 0 to 5, 0 plus 5, you divide by 2. 5 plus 10, you get 15, divide by 2, 7.5. 10 plus 15 is 25. You divide by 2 is 12.5. Always that's what we do for the estimated mean. And then now you to write them like this. Then after I've written them like this next to the classes, then you take these class midpoints. These are class midpoints. You take the class midpoints, you multiply it by the individual frequencies per class, meaning that you're going to take 2.5 times 3. 2.5 times 3. Then the class midpoint here is 7.5 times 11. And then here the class midpoint is 12.5 times what? Times 20. Here it is 17.5 times what? 17.5 times what? Times 8, because it's no longer 12, because some of them they moved from here. Because even here they said calculate the estimated mean. Okay, that's what you did. But then how did you get 630? I think you missed something. Or because this 12, how did you deal with the 12? Because some of them they moved here. There were 12 before. There were 12 athletes here, but 4 of them moved to the upper group. Because you see, calculate the estimated mean distance that the 50 athletes need to travel after 4 families have moved 10 kilometers closer to the facility. You understand? After 4 families have moved 10 kilometers closer to the facility. What's the question? If that's what you did, then how did you get 630? You made a mistake then, no? Then you missed some values here in the numerator. Because the 2.5 times 3, it's 675. I'm 100% sure about it. I'm 100% sure about it. I'm 100% sure about it. Where's the question? Who is confused here? Who is confused here? What is confusing? Please talk to me. Do this thing on a calculator, like 2.5 times 3, 7.5 times 7.5 times 11. Yeah, this method is only for grouped data. This one is only for grouped data. Only for what? Grouped data. The one of the class midpoints is only for grouped data. There's no other way for the grouped data. This is the only method for grouped data. How do you say grouped? Grouped means that there are already classes here. Class intervals. With the class intervals, then you must take the class midpoints. Always you must do that. Always you must do that. Always you must do that. Yeah, this method is for grouped data. Always for grouped data. Always to do it like this. It's already there tomorrow. This one. What's the question? It's already there tomorrow. This one. It's already there tomorrow. This one. Okay, good. I'm glad. So you can just take 2.5 times 3, 7.5 times 11. So yeah, you take the midpoints, class midpoints, and multiply by the what? By the individual frequencies per class. You add now the total frequencies per class. The total frequencies for all the classes. In this case, is 50. So you see, if you have a question, please ask. If you have a question, please ask. Right. We continue. This method is for grouped data. We always do it like this for grouped data. For grouped data. For grouped data. Grouped data. Always like this. But if it's grouped, okay, we're moving to a question that is dealing with ungrouped data. There's grouped data that is not grouped. That's a good question. What do I predict for tomorrow's stats? This question is going to be there. This one. They're just going to change from athletes. They're going to bring some choir members. You know, from athletes, they're just going to bring some choir members, or they're just going to bring some soccer players, something like that. But this structure is the one that is coming. They can just change and say, okay, but these are, instead of them being athletes, they are what? They are soldiers. They are military people in the army. They are military people in the army. They are military people in the army. The military people, etc. But is this question, find the estimated mean, is already there, this one. Find the estimated mean is already there. This is how you need to do it. 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 What's the question? This is how you need to do it. It's there tomorrow, but you must follow this pattern. You must follow this method, because tomorrow this question is already there. This question is already there. This question is already there. What's the question? Then we move on to the next one. Then we move on to the next one. Right, let's continue to the next question. Okay, this is why I always deal with the estimated mean in the case of grouped data. Always like this. Okay, yeah, so we have this one. Then we have this one. This one we did yesterday. Okay, I want us to deal with some other questions. Okay, you are saying we did not do these. Which one? Which one did not do the SETI? Because yesterday we're doing analytical geometry. Did you not do k equals 3? This one of y equals kx plus 3. Then you said you substitute and then you get k equals 1 over 3. Okay. Okay, we did question 3. Try to remember the SETI. Like we calculated the coordinates of B, and the SETI was able to get the coordinates of B, and the SETI said the coordinates of B were -9 and 0. And the SETI said, okay, we must write them in the right order. I remember that. And then we got the angle alpha, and then we were able to get the value of k. and we're able to calculate the coordinates of B. Oh yes, Lesedi now remembers, because Lesedi was able to also calculate the area here. We had to calculate the area of, it's there as part of the recording in the video. I've already sent you the video earlier today, like the area of ABD. Now the question was, with ABD, how do you find the area? Where is the height? That is what Neil asked. Now, when Neil asked where is the height, we then said you can construct the height like this, and this height is the perpendicular height. And they were like, okay, what is the height? We said the height is the y value here, which is what? Which is exactly 4, and that is the height. You see? So this one was done yesterday. Obviously, I mean, we can do it again, but I wish that we can do like new things, you know, things we have not done. Okay, let us do more statistics now, and then we shall do other things. I brought some more stats. There's more stats I was loading. By the time I was talking to you, I was loading more stats. There's this one. Okay, let us discuss this stats question. Okay, question 1. This one came in November 2023. This is mathematics paper 2, November 2023. Is also of the structure of the June 2024. It follows the exam trends, indicating what is going to come in this exam tomorrow. So obviously you can always follow those predictions. But now I would be interested in then dealing with this. Let us find the equation of the least squares regression line. Truck drivers travel a certain distance and have a rest before traveling further. A driver kept record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes before he continued his journey. The information is given in the table below. Determine the equation of the least squares regression line. Please find the equation of the least squares regression line, and then we can continue. So please just try that one. And then once you're done, you let me know. Yeah, just do the least squares regression line, please. Yeah, we shall go until after 8, and then we shall give you time to do other things. But yeah, there are things we need to. I'm trying to perfect your statistics here. Okay, let's say it's done. Please try it now. I want to see what, because I want you to compare, like, all right, 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 right. Okay. Now, for example, if you look at this, we are asking the question. Yeah, you see? Okay, now it's done. Let's just practice with it because it's just practicing. So now we're gonna do the calculator. Let's just do the calculator together. Okay, should I? Okay, I don't want to put you on the spot. I don't want to sound rude. I don't want to sound what? I don't want to sound rude. Top is X and bottom is Y. So we're gonna put the calculator here. Then we're gonna do this one, and then we're gonna do 3 stats. And then we need regression. So we're gonna do 2a plus bx. Then x is this one, which is 180 first. Then we have 200. Then we have 400. Then we have 600. Then we have 170. Then we have a 350. Then we have 270. Then we have 300. Okay, then we go back to the top. Then we have 20. We have 25. We have 55. We have 120. We have 15. We have 50. We have 40. We have 45. Okay. Then you go shift 1, start. Regression analysis 5. A is 1, which is minus 23.85. Minus 23.85. So A minus 23.85. Let's do B. Right, minus 23.85. Let's do B. Shift 1, regression 5. Then we want B2. Yeah, it appears that B is 0.23. I'm going to check this. 0.23. Okay, yeah, I'm going to check these things. I'm going to check if this is correct or what. If there's a mistake, I will pick that up. If there's a mistake, I'll pick that up. All right, so now you're dealing with the right. So you continue. Let's just check. Okay, I'm just checking if these things are correct. I'm just checking if these things are correct. Yeah, that is correct. So, which means that the equation of the least squares regression line, call it y hat, which is minus 23.85, 0.23x. Right. Okay, that is the answer. So now, if a truck driver has traveled 550 kilometers, predict the amount of time in minutes that he should rest before continuing his journey. What is the prediction? If a truck driver travels 550 kilometers, now x is the distance in kilometers, the amount of rest time. So if x is 500 and what? Is 550 kilometers, what is the rest time? Y hat. 0.85 plus 0.23 x. Zero 0.23 x is 550. Yeah? What did you get? You got 102.65, yeah? You got 102.65. Yeah, that's correct. So in this case, it means therefore that y hat is 102.65. Then interpret your answer to in that question. 1.4. Interpret. Okay, yeah, sorry. This one, we also need 1.3, the correlation. Right, so good. the correlation coefficient. I got a correct answer from one of you. So obviously now to get the correlation coefficient, shift 1. Now you can do regression 5. And then 3, 0.98 is the correlation coefficient. So the correlation coefficient is R equal to 0.98. Interpret your answer, because the 0.98 is close to 1. We say the interpretation, if it is close to 1, we say it is very strong. If it's close to 0, then it is weak. But here it's very strong positive correlation. Positive what? Correlation. Very strong positive correlation. Very strong positive correlation. Very strong positive correlation. Why? Because it's 0.8, it's approximately 1. So it's very strong positive correlation because the correlation coefficient is approximately what? It's approximately 1. Where's the question? Who is confused? Who wants to ask something? Who wants to ask about statistics? You must get 100% in statistics tomorrow. You must get exactly these 100% in statistics tomorrow. Where's the question? Okay. Okay, my apologies because the network became weak, but we're back. Welcome back. The network became weak, and so I lost connectivity. Are we together? The network became what? It became weak, and therefore I lost connectivity. The network became weak, I lost connectivity. The network became weak, and therefore I lost connectivity. The network became weak, and I lost connectivity. The network became weak, and I lost connectivity. Okay, so we're back. Yeah, thank you so much for, yeah, we got that. At each stop, the truck driver spent money buying food and other refreshments. The amount in rands is given in the table below. Calculate the mean amount of money he spent at each stop. Okay, now we need the mean. What is the mean here? Calculate the mean very fast. Calculate the mean very fast. Calculate the mean very fast. Calculate the mean quickly. Calculate the mean quickly. Okay, now got 150. Now got 150. And they said it got the same thing. Let us check that out. Let's use a calculator quickly. Right, using a calculator, we're going to give the following. Right, we're going to have the following. So now, then you're going to do what? You're going to do mode 3 stats. Then we are dealing with one variable. Then you're going to put 100, 150, 130, 200, 50, 180, 200, 190. Oh, okay. I have my calculator. I need to bring it back. So 190, then you have that. So it's okay. Then shift stat. Then now, obviously, at this pointer, we want to get 4. We want to get the mean 2, 150. So obviously here, this one is x bar equals 150. Calculate the standard deviation. What is the standard deviation, please, quickly? Who has got the standard deviation? Who has got the standard deviation? Who has got the standard deviation? Right. Done. Okay, yeah, I've seen that. So let's see 4 variants. And we have the standard deviation. Yeah, 0.2. Right, which is 3. 50.50. 50 point what? 50. Which means that sigma is 50.50. 50.50. 50.50. And how many stops did the driver spend an amount that was less than this, less than 1 standard deviation below the mean? Do 1.5.3. And how many stops did the driver spend? Yeah, at 1 stop. Well done, Lisedi. Because that is going to be exactly x. 1 standard deviation, less than 1 standard deviation below the mean. Now, because they said below the mean, then you must subtract the what? You must subtract the standard deviation from the mean. And therefore, you know that the mean is 50. And this one is 50.50. And therefore, this is 99.50. 99.50. And therefore, at this point, if it is 99.50, you actually obviously would be in a position to say at how many stops. So how many, therefore, obviously are actually less than these, right? So you are able to see clearly here that it is exactly that one there. So that is, therefore, there is 1 stop. Right. 1 stop. 1 stop. Where's the question? Where's the question? Okay, yeah, let us do some other questions that I want us to practice, like similarity and proportionality, but also let us do 3D trig, then graphs. Okay, let's do the 3D trig. Okay, let's do question 7. Right, question 7 in the diagram points what's deviation? Deviation would be below the mean, obviously, as we've already seen, that below the mean is what? Is x minus the mean. x minus the standard deviation. This will be below the mean. That is one standard deviation below the mean. One standard deviation below the mean. Okay. Okay, yeah, okay, yeah. Never said she lost the connection. Okay, this is being recorded, so you'll watch during your own leisure. Okay. Okay, now you have the what is the value? Okay, because now then the mean is 150 and then the standard deviation is 50.50. It's 50.50, which means that now the sigma, now x bar minus sigma, 150 minus 50.50. Did you get 50.49? Okay. How did you get 50.49? When you said x bar minus sigma, okay, if you round off, then it's 50. Oh, yes, yes, sigma, 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 sigma. Yeah, this one, 50.49, etc. Yeah, this one is okay for the standard deviation. You round off, yeah? You round off. 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 Okay. All right, good. I wanted us now to go to this one. There are many questions I were planning, but I know very well time might not allow us to go through all of them. But let us try this one. Let us try 7.2. Right, so 7.2 now. I want us to do 7.2.1. Quickly, please. In the diagram, points B and C lie in the same horizontal plane. B, C and D, they lie in the same horizontal plane. ADB and ACB. So ADB and ACB equal alpha. And the angle CDB equals theta. And the DK is equal to what? And rather DC. DC is K units. Okay, you got 7.2. What did you do, Lesedi? Right, obviously in 7.2.1, you need to prove that AD is equal to what? Is equal to AC. To prove that AD is equal to AC. Okay. Let me see what Lesedi did there. Yeah, AB equals that. Yeah, you use the similarity and proportional. You use the congruent triangles, yeah? Okay, so yeah, you're right. But yeah, the couple of ways obvious to do it. Yes. Okay, good. So you're on point there. But you see, in 7.2.1 can be done in so many ways. In so many ways. So 7.2.1 in triangle ADB. Okay, so here what you do is you're gonna take this, the sign of alpha, which is opposite of hypotenuse. Yeah, which is opposite is AB over hypotenuse AD. Right, so we can then be able to make AD the subject, which means AD is AB over sine alpha. In triangle ABC, ABC, which is the sine of alpha, which is opposite, which means that AC is AB over sine alpha. So now, therefore, if this is AB over sine alpha, AB over sine alpha, it means that AD is equal to what? Is equal to AC. AD is equal to AC. It means that AD is equal to AC. 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 Okay, but do say 7.2.2, guys. Yes, you can do it like you did, Lisedi. You can use your similarity and proportionality and so on. It's okay. It's fine. It's fine. Okay, now do 7.2.2. Prove that BD is equal to that. Right. So continue. We continue. Oh yeah, can you please try to do 7.2.2, guys? 7.2.2. When you're done, please let me know. Yeah, do 7.2.2. When you're done, please let me know. When you're done, please let me know. Right. Okay. Okay, which lines are parallel, yeah? Which lines are parallel? Because we're doing 7.2.2. We're doing 7.2.2. Please do 7.2.2 quickly. Please do 7.2.2 quickly. Please do 7.2.2 quickly. Yeah. Okay, yeah. You see, where are you? You are speaking about parallel lines now. We are speaking about parallel lines. Okay, yeah, equal lines, equal lines, equal lines, equal line segments, like AD equal to AC, but they're not parallel. They're equal, right? AD is equal to AC. They're equal line segments, but they're not parallel. Yeah. All right. Good. Yeah, I was wondering the parallel lines. So please try 7.2.2. Okay, what rule did you use, Lisedi? Okay, yeah. Use the sign opposite of hypotenuse, yeah? Okay, that's fine. That sounds interesting. We're doing 7.2.2, yeah? All right. Right. To continue. So any question? Who is confused here? Well, yeah, we're trying 7.2.2, please. 7.2.2. Yeah, 7.2.2. Okay. Oh, okay. Right, because we want to do 7.2.2, and to do 7.2.2 in triangle BDC. Right, so you already know that this one is theta, but since this side is equal to this is also what? This is also theta, and these are base angles of the isosceles triangle. Okay, so now what you're going to do, therefore, we're going to work in that triangle. So this one is going to be 180 degrees minus 2 theta. Okay, good. Yes, which triangle should we use? So obviously it can be any triangle, but it is a triangle that is the side BD. And the triangle that is the side BD is the bottom triangle. Yes, the sine rule, because there are no square roots and other things. Here we're going to use the sine rule. We're going to use the sine rule. And then now we need BD, so we're going to say BD in the triangle BDC, so BT over sine theta K over sine 180 degrees minus 2 theta. Okay, which is K divided by the sine of 2 theta. So which means that BD, which is K sine theta divided by the sine of what? Of 2 theta. But you already know that the sine of 2 theta, check the back of the question paper, double angle formulae. It's 2 sine theta cosine theta. And so the sine cancels, and this gives us K divided by 2 cosine theta. K divided by 2 cosine theta. Um, right. Right. You continue. Right. You continue. Right. Okay, let's see. Okay, we continue. Now let's look at the last question. The next one, 7.2.3. Determine the area of the triangle BCD. Determine the area of the triangle what? BCD in terms of K and a single trigonometric ratio of theta. What is the area of this triangle? BCD. What is the area of the triangle BCD? The area of the triangle BCD. Right, so you continue. So you continue. Yes. Yeah, I can display the formula sheet, but just I did not load it. I did not load it, so right, so we continue. Right. Okay, so now when we find the area, So we're going to say the area of triangle BCD one half BD BC, the sine of this angle is 108. This angle here is 180 degrees minus 2 theta. Which is one half. The BD is K over 2 cosine theta. The BC and the BD are the same. So it will just be because this and that are the same. So it's going to be this one as a K over 2 cosine. The sine of 180 minus, it's going to be the same as the sine of 2 theta. So that in the end, then you have 2K squared sine theta cosine theta divided by 2 times 2 times 2. 2 times 2 is 4 times 2, which is 8. Cosine theta, which is 8. Cosine theta, cosine theta. All right. So what you then have is the following. 2 goes 4 times here. Divided by 4 cosine theta. That is the answer, but this is k squared. Sine k squared over 4. Sine over cosine is what? Is 10 theta, which means that the area is this one. The area is therefore k squared over 4 10 theta. Where's the question? So because how do you find the area? There are the area formulas, like area is half AB sine C, half BC sine A, half AC sine B. So there are 3 area formulas we need to learn. Right. Okay, how did you calculate out the numbers? Right. So how did you calculate out the numbers? How did you calculate out the numbers? Which numbers? Which numbers? Okay, like the 180 minus 2x minus 2 theta, because it is exactly this angle here. It is exactly this angle here. The 180 degrees minus 2 theta is exactly this angle here. Or the 2 over 8. Yeah, the 2 over 8. Okay, because there is half, 2, 2. 2 times 2 is 4. 4 times 2 is what? It's 8. Then sine 2 theta. What is sine 2 theta? It is 2 sine theta cosine theta. Sine 2 theta is 2 sine theta what? Cosine theta. Sine 2 theta is 2 sine theta. That's why where the 2 is coming from. But obviously now we just simplified here because now you have the 2 and the 8. 2 times 2 is 4 times 2, which is 8. So 2 out of 8 is 1/4. Two out of 8 is 1/4. Okay, any question? Any question? Okay. All right, good. Let's look at the next question. Let's look at the next question. Now, I want us to look at I want us to look at the graphs a little bit. I want us to look at the graphs. I want us to look at the graphs a little bit. In the diagram, the graphs of f of x equals cosine x plus a and g of x equals sine 2x are drawn for the interval minus 180 to 180. The graphs intersect at n equals minus 75 degrees and k, and p coordinates 45 degrees and 1, q coordinates 165 degrees and k. P is also a turning point of both graphs. Write down the period of f. Who can write down the period of f? Because the equation is actually the cosine of x plus a. Who can write down the period of f? Please write it down. Right. 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 Continue. Okay, I've seen Neo's answer. What is your answer to the period of f, Lissetti? If f of x is equal to the cosine of x plus a, what is the period here? What is the period of f? So you always say the period, yeah. Okay, they say the things that way. But for the period, you need to say 360 for sine and cosine. Right, for sine x, you can say, and the cosine x. So it's 36 degrees divided by the coefficient of the x, which is 1. And therefore, it becomes 360 degrees. So the period of f is exactly 360 degrees. Where's the question? If the period is 360 degrees, where's the question? Who does not understand what to do? Who does not understand what to do? Right. We continue. Right. We continue. We continue. Right. Okay. Write down the amplitude of G. What is the amplitude of G? If you already know that G of X is what? Is sine 2X. What is the amplitude of G? What is the amplitude of what? Of G. Please let me know if you can get this one. Amplitude of G. What is the amplitude of G? What is the amplitude of G? Yeah. Right. Amplitude of G is exactly a 1. Well done there. Obviously, you can see the amplitude of G is can be seen as part of the coefficient, and therefore the amplitude of G is 1, because you can see it is 1 here. But also, if you look at the graph of G, which is this one here, It goes up to 1, it goes down -1. So you can see, therefore, the amplitude is 1. Where's the question? Okay, next question. All right, let's try the next one. I know that obviously we're beyond time. Okay, write down the value of A. Write down the value of A. Because this question is there. That is why I'm saying you need to discuss. This is the kind of question, typical exam question you're going to meet tomorrow. Okay, if we're dealing with the cosine of x plus A, then what is the value of A? What would you say the answer is here? But A is called what? A is called a phase shift. It's called what? A phase shift of the graph. So the graph undergoes a phase shift by an amount A. But by what amount would this graph undergo a phase shift? From the standard cosine graph, because the cosine graph standard would be doing this. Yx, Yx, Yx. So, but now at 0, like we know that cosine 0 is 1. So at 0, the cosine is 1. But now you need to look at how much it has moved. How much is it moved? It has moved. But also you can take a point and calculate the value of A. Like you can say the graph of F and G, they pass through the point P. So you can say through P, and P has those coordinates. I mean, you can take a point and substitute. You can say through P, P is 45 degrees 1. X is this, which means Y is 1. X is 45 degrees plus A. Then you can solve for A. Because here is going to be arc cosine 1, which is 45 degrees plus A. Then what is arc cosine 1? Right, you can see that arc cosine 1 is equal to what? When is the cosine? It is either 0 or that. We choose 0. Or 2 pi. Or rather what you call 360 degrees. But we choose 0. We choose the smallest one. And therefore A is equal to minus 45 degrees. But also you can see it's minus 45 degrees. Or alternatively, you can see that the cosine of 0 is 1. But this graph is now no longer here where the cosine is supposed to be. Cosine is supposed to be here because cosine 90 is 0, but cosine minus 90 is 0, cosine 90 is 0. Cosine 0 is 1, but it has moved now, this graph. It has moved 45 degrees. So the graph has moved 45 degrees right. So how do you say something has moved 45 degrees to the right in mathematics in terms of the in terms of parameters? So you then say x minus what? X minus 45 degrees. This would mean 45 degrees to the right. So you can either do it by inspection, looking at by how much the graph has moved, or you can take one point and substitute into the equation to get the value of A. Who has a question about this? Who is confused? Who does not understand what I was saying here? Right. Who does not understand what I was saying here? Right. Okay, now please, can you try 6.4? Can you try 6.4? Can you please 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 try 6.4? Calculate the value of k, the y coordinate of n and p without the use of a calculator. What is the value of k there? Lisedi. Neo. What is the value of k? The point is already there. Substitute into one of the equations. If you need to find a coordinate, like here, you need to find k, which is a y coordinate. Substitute into a known point and get the coordinates of that point. Substitute into a known point. Substitute into a known point. Okay, we want the value of k now. Let's say, what is the value of k? What is the k? The k is there, 165 degrees and k, but also minus 75 degrees and k. But calculate the value of k. What is the value of k, let's say? And now, what is the value of k? 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 Let's say, how far? What is the value of k? Let's say, what is the value of k? Now, okay. Now, what is the value of k? Right, so I'm waiting for now also. So now what you need to do here is to look at one of the equations, but these two graphs intersect. So it means therefore we have g of x, which is the sine of 2x. Okay, but it passes through a point N. So you need to write through N with coordinates minus 75 degrees and K, which means this is X and Y. So the Y is K. The X is minus 75 degrees. So K is the sine of 2 times 75 is minus 150 degrees. And this is minus the sine of what? Of 150 degrees. What is 150 degrees? Is 180 degrees minus 30. By the cast rule, 180 minus is here. 180 plus is here. 180 minus puts you in the second quadrant. The first, the second, the third, the fourth quadrant. 180 minus puts you in the second quadrant, in which the sign is what? Is positive. So that then you have the sign of 30. What is the sign of 30? It's exactly minus 1/2, so the k is minus 1/2 there. What's the question about this? This question is already there. This one is already there tomorrow. It's already there tomorrow. Where's the question? Right. So make sure you understand it. I'm trying to highlight the things that you're going to meet tomorrow. I'm trying to highlight the things that you're going to meet tomorrow. Okay, let us move to the next question. Okay, let me give you a second. Look at this and make sure you understand it. Look at this and make sure you understand it. If you understand it, please let us know where you don't understand. If you don't understand it, please let us know where you are lost. Right, so calculate the value of k, the y coordinate of n and q without the use of a calculator. Calculate the value of k. Any question now? Any question now? Okay, I'm moving to the next question. Calculate the value of x if g of x plus 60. G of x plus 60 degrees is equal to f of x plus 60 degrees. Calculate the value of x. Calculate the value of x. Calculate the value of x. Right. Calculate the value of x. Right. Calculate the value of x. Please try it. Right. Right. We continue. Please solve for x there. Solve for x there. Right. What is the value of x there? Neolisedi. What is the value of x? But this value of x must be in a given like interval. Okay, it must be like in a given interval. What is the value of x there? What is the value of x there? What is the value of x there? Yeah, I'd lost now. What is the value of x, Lesedi? Right. Okay. Now, what is the value of x? We're doing 6.5. I'm gonna stop at 9. Oh, yeah, I'm gonna stop at 9, I think, because I must give you time to think about this stuff. Right. We continue. We continue. We continue. How far is Eddie? Okay, but obviously because x must be actually in this interval, you need to solve for x. Okay, let's say it's saying it's dark. Now, what do you think is the answer to this question? You need to solve for x, where g of x plus 60 degrees is equal to f of x plus 60 degrees. X is an element of this interval. Now, this trans x saying x plus 60, it means that 60 degrees left. If you add, it means that 60 degrees left. So the graph is going to move 60 degrees to the left. So now, obviously, you need to look at where the two graphs are equal to each other, but 60 degrees to the left. So which means that you're going to take a point like 45, right? A point like 45, and then you subtract. Right, so a point like 45, we continue. A point like 45. So you're going to say 45 degrees minus 60. And then it is going to be what? It is going to exactly be minus 15 degrees, yeah? So when that happens, then you're able to get the answer. Yes. Okay, what is K? This one. What is K? K is where the two graphs meet. Where the two graphs meet. Yeah, we got K to be minus 1/2. We got K to be what? We got K to be minus 1/2. We did it here. Okay, good. We got K to be minus 1/2, and we did it over here. We did it over there. We did it over there. Right, we did it over there. So now, one determine the value, the values of x here. One determine the values of x. Right, 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 right. So you continue.
Yeah, so it's like, what should I do? What should this is a whole like something.
Okay, yeah, let's check. Okay, yeah. I want us to do this one. Oops, this thing has filled the whole screen. I want us to right. All right. We start with a calculator to like determine the number of solutions the equation has in the interval between minus 90 and 90 degrees. Clearly show all you're working. Okay. So, okay, yeah, please try 6.6, please. 6.6, please. Try 6.6, please. Right. 6.6, please. How do you know? How do you know? Yes, I agree. I agree. I agree. One solution. Right. So obviously, this, yeah, that's, you're right. Right. We continue. So you then, we continue. Okay. So what you need to do now is to consider 6.6. To consider 6.6. Right. So obviously for 6.6, what we're having is that we've, okay, good. So you have the square root of 2 sine 2x, which equals sine x plus cosine x. Sine 2x is divided by the square root of 2 sine x plus 1 over the square root of 2 cosine x. And this thing here is just the same as, because we had here that this cosine was what? Was x minus 45 degrees, yeah? So that this one is x minus 45 degrees. Right. So now it means, therefore, we're looking for solutions where g of x, because yeah, this is like sine 2x, it's not just sine x. So this would mean that g of x is equal to f of x. G of x is equal to f of x. So it means that this equation here is saying, where are these two functions equal? But between minus 90 and what? And 90 degrees. Between minus 90 and 90 degrees. Between minus 90 and 90 degrees. Where are these two graphs equal to each other? right? And so you can see, therefore, that between minus 90 and what? And 90 degrees, what, how many points of intersections exist? Okay. The number of the solutions. The number of the solutions, if they say determine the number of the solutions, they need the points of what? They need the points of intersection. The question is, how many points of intersection are there? And 6.6. So in other words, you'd have two roots in the interval. In the interval x element of minus 90 degrees. Yeah. X element of minus 90 degrees to 90 degrees. X element of minus 90 degrees to what? To 90 degrees. So there are 2 points of intersection between minus 90 and 90. They say there's 1 and then 2. Those are the points of intersection. Right. Okay. Okay. Now we're saying notes. Okay. Yeah, well, we're saying two roots. Two roots. Because the number of the solutions tell us the two roots. The roots, if we say two roots, we mean 2x values. 2x what? 2x values. That's what we mean by the roots. We mean roots. If that is what Neo was inquiring about. But I must give you a chance to be on your own and think, because now I'm just thinking, I don't want to just be like a parrot that is just singing, singing, singing. What is the next thing that you need to do? Okay. So the other questions that I want to bring to your attention, let us do similarity and proportionality. Let us do similarity and proportionality. What we're going to do this one. Right. So now, doing similarity and proportionality in the diagram, COD is the diameter of the circle with center O. EA is the tangent to the circle at F. You have that EA is the tangent to the circle at F, and AO is perpendicular to CE. Right. AO is perpendicular to what? To CE. And the COD produced intersects the tangent at E. You have the tangent at what? At E. Right. OB produced intersects the tangent to the circle at A. There it is at A. Right. So OB produced. So when you look at OB produced, so this OB produced, what is the significance of this? It means therefore OB is a straight line, but also it means that OO is what is a straight line. Now CF intersects OB in T there. CB, BD, and OF and FD are drawn. Prove with reasons that TODF is a cyclic quadrilateral. Okay. So now, okay, prove with reasons like TODF is exactly quadrilateral. So how do we prove this one? How do we prove that TODF is a cyclic quadrilateral? TODF is a cyclic quadrilateral. Let's look at this. So you have TODF is a cyclic what? It's a slightly quadrilateral. So one way to do this will just be to show that the angle O1 is equal to the F2 and F3. We'll have to show that this angle is also 90. If this angle is 90 and that angle is 90, then we're done. I'm going to start by saying the angle O1 equals what? 90 degrees, given. Yes. Okay, your. So, well done. Angle F2 plus the angle F3, excellent. F2 plus the angle F3 is 90 degrees. And the reason is that it is an angle in what? Angle in semicircle. So this one is 90 degrees because it's an angle in what? In semicircle. By dint of that, it means therefore the angle O1 is equal to F2 plus what? F2 plus F3. Angle F2 plus angle F3. And this is equal to what? 90 degrees. And as a conclusion, therefore, is that TODF is a cyclic quadrilateral. It's a cyclic quad. Why? What is the reason for it to be a cyclic quad? Because the exterior angle is equal to the interior opposite angle. The exterior angle is equal to interior opposite angle. The exterior angle equals the interior opposite angle. Where's the question? Where's the question? Where's the question? Who does not understand what to do here? Who is lost and who is confused? The next question is question 10.2. How do you prove that D3 is equal to angle D3 is equal to the angle T1? How do you prove that the angle D3 is equal to the angle T1? So this one is very easy, this one of 10.2, because we know that this angle T1, the angle T1 is equal to the angle what? T3. These are vertically opposite what? Vertically opposite angles are equal because the angles in X like this, we call them vertically opposite angles. So this is like X, so T1 equals T3. These are vertically opposite what? Angles. But we also have that the angle D3, the angle D3, this one, is equal to the angle T3. Okay. Is equal to angle T3. And the reason for this is that when you have the exterior angle of cyclic quad, exterior angle of cyclic quad, exterior angle of cyclic exterior angle of cyclic quad. So this D3 is equal to T3. So as a conclusion, the conclusion therefore is that T3 is equal to T1, but T3 is equal to D3, which means that the angle T1 is equal to the angle D3. The angle T1 is equal to the angle what? The angle D3. So the angle T1 is equal to the angle D3. The angle T1 is equal to the angle D3. Who does not understand anything? So we've done the 10.1 in red. So we're supposed to prove right now, or you can say, therefore, D3 is T1, yeah? You can write it like the way it has been given. But if you are lost, please talk to us. D3 is equal to T1. The angle D3 is equal to the angle what? T1. D3 is equal to the angle T1. D3 is equal to the angle T1. Okay, where's the question? Who does not understand what to do? Then now we're going to look at what? We're going to look at because now it's very easy to see that the angle D3 is equal to the angle what? Is equal to the angle T1. Because D3 is equal to the same as T3 and exterior angle of cyclic quad, and the T3 is equal to T1. These are vertical opposite angles, and we've shown therefore that the angle D3 is equal to the angle T1. Right, and the marks are 3 there. So now you need to show that the angle TFO is similar to the triangle. The triangle TFO is similar to the triangle DFE. Is similar to the triangle DFE. Is similar to the triangle. So the triangle TFO is similar to the triangle what? The triangle TFO is similar to the triangle DFE. Oh, yeah, these triangles. Yeah, 5 marks, 5 marks. Let's spend some time on that one. Let's spend some time. Yeah, I want us to discuss just similarity and proportionality briefly so that you can just revise those. Okay, let us look at 10.3. Okay, obviously at this point, we need to prove this. So in triangle, so we're going to work in triangles. In triangle DFE, and triangle TFO, number one. Let's look at the triangle DFE. Let's highlight them. So if you look at the DFE, it's this one. It's the blue triangle. And then now we're going to actually highlight the other one in red. Okay, D3 equals F1. Okay, that's interesting, Lesedi. So you have TFO. TFO. Right, so let me see what Lesedi was saying here. You're saying D3 is equal to F1. Okay. D3 is equal to F1. I agree with you, but I'm interested in the angles that lie inside the red one. Yeah, D3 is T3. I agree with you. The angle D3 is equal to the angle what? T3. So the angle D3 is equal to the angle T3. And the reason for this is exterior angle of cyclic quad. Exterior angle of cyclic quad. Next, what is the next point? If D3 is equal to T3, if D3 is equal to T3, Okay. So now it is true we've taken that. So we just need another angle that is going to work here. So it is clear that the angle F4, let's use a different color. Let's use the blue color. The angle F4, which is this one, is actually exactly equal to the angle C2. F4 is equal to C2. Ten-chord theorem. Right. Ten-chord theorem. So F4 is equal to what? Is equal to C2 by the ten-chord theorem. That is clear. But the angle C2, the angle C2 is equal to the angle F2. The angle C2 is equal to the angle F2. Angles opposite equal sides. Therefore, the angle F4 is equal to the angle F2. Because F4 is C2, C2 is F2, which means F4 is F2. Good. Now, we have the two angles, so we have found that F4 is equal to F2. Now, the third angle. So now, point number 3, you would actually therefore be in a position to see the third angle. So which means therefore you would have the angle E. Right, you therefore have the angle E would be equals to the angle O2. Because we not mentioned, so which means E is equal to the remaining angles, because the red is equal to red, the blue is the blue, so E and O2 are the ones that are left, so E is equal to O2, third angle of triangle, third angle of triangle. Therefore the triangle, therefore the triangle, therefore the triangle TFO, right, therefore the triangle TFO is similar to the triangle, right? So we write them in order. You have already seen that T is equal to D. So T is equal to D. And then, yeah, F would also be, F2 is F4, so F would be F. And then O, the center, is equal to E. Is equal to E. And the reason for this is angle, angle, angle. Angle, angle, angle. Right, angle, angle, angle. So we've proven that. What's the question? Good. We have proven, therefore, that these two triangles are similar triangles. And now the proof is very clear that the triangle, good, good, good. Right, in the absence of questions, then we move on. I know that we need to conclude our discussion. Let's move to question 10.4. We're going to send you this recording, please. We're going to send you this recording so you can watch. 10.4. 10.4. If B2 is equal to angle E, the angle B2 is equal to the angle E. Prove that DB is parallel to EA. Prove that DB is parallel to EA. So now at this point, what you need to do here is to say, the angle B2 is equal to the angle D1. Okay, we are saying the angle B2, which is this one, is equal to the angle what? Is equal to the angle D1, because these are radii. This is a radius and that's a radius. So these are actually angles opposite equal sides. Angles opposite equal sides. Angles opposite equal sides. So that B2 is equal to D1. But we've been told here that B2 is E. B2 is equal to 1 because this is a radius and that's a radius. Okay, let me see. Okay, yeah, that's interesting. Yes, that means they're corresponding angles, yeah? Because the B2 is E and it was given that way. Therefore, the angle D1 equals E. Therefore, DB is parallel to EA. Corresponding angles equal. Okay, because we have shown therefore that the D1 is equal to what? It's exactly equal to, the D1, angle D1, right? The angle D1 is actually exactly equal to angle E. And we are back to grade 10 now. If you have that an angle that is sitting here is equal to the angle that is sitting there, then obviously it will mean that these are corresponding angles, and therefore these lines are parallel, and therefore it would mean therefore that DB is parallel to EA because the corresponding angles are equal to each other. Equal to each other. So now I want us to actually discuss this result there on the proof of this. So now we actually are interested in proving 10.5. We're interested in proving 10.5. Right. 10.5. 10.5 is the next one to prove. And then I'm going to give you a break. We're just discussing similarity and proportionality. Okay, but you have the theorems to study, to revise, please, guys. Those theorems, they can ask you to prove some of the theorems. Like, what theorems are they going to ask you to prove? The 10-chord theorem we did earlier. Angle at center is twice angle at circumference. I can ask you to prove. The opposite angles of a cyclic quad are supplementary. They can ask you to prove. So those are the kinds of things you need to remember. Okay. Those are the kinds of things you need to remember. Those are the kinds of things you need to remember. 10.5. 10.5. In triangle OEA, want to prove this one. So now we actually need to look at the fact that to prove this one of the things we need to prove would be the results. We need to be able to use. We need to be able to have your OD, like it appears here, or the DO, and then we must have also. We're gonna have DE as well. And then we're going to have, because now we've already proven that these are parallel to each other. So having proven that DB is parallel to EA, then we can be able to do some of the things. So I'm going to say in triangle OEA, which is the triangle we want, we already have parallel sides, and then we can use the proportionality theorem there, and then we are done to prove this one. So in the triangle OEA now, we know very well that in this particular triangle, DB is parallel to what? Is parallel to EA, which means that OD over DE is OB over BA. Right, there are two ways to state this one. We just say the prop theorem, then the examiners will know very well. If you just say prop theorem to mean proportionality theorem with DB parallel to EA. Okay. And then you can actually be in a position to cross multiply, make DE the subject here. So if you make DE the subject of this equation, it becomes DO AB over OB. So DE is DO AB over OB. You can write that one. So from the proportionality theorem, we've got this one. So now it is some AB in it. But now we need to get more things. There's a DO, but yeah, we don't have DE there. The reasons why obviously would not have DE. Let's continue with our investigation. Okay, if you have, for instance, FO over FE, FOF over FE. Okay, we need also that because the FE must be there. So now we need, for instance, FO over FE. From the previous results, I want to say that one. So the best way to do it is to say, since triangle TFO is similar to triangle DFE, which means therefore we have FO over. So you can take this one over FE. Okay, this one is from the previous question. From, we can say, since this is the case, and you see, the reason you put here, you say proved. Proved in 10.3. Proved in 10.3 above. Okay, at this point, then you can say FO over FE. FO over FE is equals to TO. So you take TO over DE. Okay, we're just mentioning the things that appear. And then you can make DE the subject out of this. DE is going to be TO FE over FO. Okay, so now what you're getting here is therefore that there are two formulas for the DE. You have that DE is equal to this one here in the green, and then you have a DE is equal to this one also. So they're both DE this. This one came from the similar triangles, but this one came from the what? From the proportionality theorem. So now you can get things from the proportionality theorem if they're parallel lines like you've proven, or now you can get things from the what? From the similar triangles if you've proven triangles to be similar. At this point, the conclusion then becomes the following. Then we conclude and say, therefore, you say DOAB over OB is equal to TOFE over FO. Okay, so this is equal to DE and this is equal to DE. So now you can conclude that these are equal to each other. But now you need to just be in a position to manipulate this correctly and get the required result. Now, OB, FO, they're from the center. Okay, OB, FO, each one of them is a radius. So you can choose any one of these. So here you can come and then say, you have DO, AB over DO is equal to TO FE over DO. So obviously at this point, these are the reason for this one is that you have that the DO, we can see that DO is equal to what? DO is equal to OB, and this is equal to FO. Is equal to FO. These are radii. These are what? These are radii. Right. So now these denominators are the same. These denominators are the same. So we're going to just conclude it over here. So that now in the end, this DO is like this DO, it cancels out. And then the observation is therefore how far away. So you have DOAB and everything is there. So which means that you have DOAB TOFE, which means that DO is equal to TOFE over AB, which is this one, which is that one. Okay, so we played around with this one. We used the proportionality theorem, but we also used the similar triangles to get these complicated thing. So this is the sort of thing sometimes you must learn from the problems and have smarter ways to prove the results. But we must thank you for joining us. It was awesome having this discussion. Let me give you a break, guys. You need to sleep before tomorrow. It's just after 9:30. Okay, right, good night. I'm sending the recording the next couple of minutes, okay, so that you can watch this recording and you can ask me questions if you have any questions on WhatsApp, or you can send your questions in the we can um right, right. So yeah, any questions? Where's the question? I'm sending this recording now so you can watch all the things we've done today on the statistics, on whatnot. So on the Euclidean geometry and the other things we've done. I wish obviously to do more, but yeah, it's there's always so much you can do. Okay, bye guys. It's good night. Good night to you. All the best for tomorrow. All the best, and God bless you. May God give you so much wisdom, like wisdom to think fresh. But you need to sleep before tomorrow. The best would be you sleep a little bit early and then you can wake up early. If you sleep very late, then it will be hard for you to wake up in the morning, which is not good. Set your alarm, whatever you can use to wake up. All right, I'm setting this recording just now on WhatsApp. Now. All right, thank you guys. Bye. Until tomorrow, all the best. Enjoy your mathematics. Get distinctions tomorrow, please. God bless you. Good night. We continue.